This is a short video, and I'm gonna use some questions that you asked me to solve for a midterm review. So I'm gonna fit them all in 30 minutes and make a 30-minute video for you to look at these questions and study over them. Here's the first question. I don't have a picture of it, so I'm just gonna draw it for you as I'm explaining. So they give you a 100-story building. So I'm gonna have 100-story building. So there's 100-story, not 100 meters, but 100-story building. And they tell you that in 1 second, the ball released from the 100th floor will travel 1 floor down. So this will be the 99th floor. And the question is, how many stories will it travel in 4 seconds? So at first I'm going to look at the distance it traveled in 1 second. So, or the height of 1 story. So the height of 1 story is the average velocity times the time. In 1 second, the velocity is going to be 10 meters per second. And the initial velocity was 0 meters per second. So the average velocity is 5 meters per second, and the time is 1 second. So the distance it travels in 1 second is 5 meters, and that is the height of 1 story. Now I want to calculate how many meters it will fall in 4 seconds. So in 4 seconds, the velocity is going to be 40 meters per second. Then the height that it will travel in 4 seconds is equal to the average velocity times the time. So you start with 0 and then you have 40, average is 20, times the time, 4 seconds, that is 80 meters. But 1 story is 5 meters and it will travel 80 meters. So how many stories does it travel? So if I want to calculate how many stories will it travel, then I can say that, so the number of floors it travels is 80 over 5, which gives me 16 stories. Here's another interesting question. I'm gonna change it a little bit so it doesn't align with College Board questions, so it's going to be a little bit different. So you have a stationary object explodes, breaking into 3 pieces, and the masses of those pieces, so there's going to be 3 pieces breaking, and the masses of those pieces are going to be, so let's say the red one is one of the masses, and it's going to be m. Another mass is going to be 2m, and the third mass is going to be 3m, and I'm not going to draw the picture where 3m is located yet. So the 2 pieces of masses like m and 2m will travel at right angle with each other and at the same magnitude of v. So each one of them is traveling with the velocity v at the right angle with each other. And then the question is, what is the magnitude and the direction of the velocity of the piece having 3 times the mass? So there is another mass that is 3m, and I want to know in what direction it will be traveling. So I redraw the picture because I want to show you it this way. So if this is momentum mv and the other one, the momentum of the other one is 2mv, I'm going to complete the parallelogram, and the resultant momentum of this system is going to be in this direction. And the momentum, it's the letter P, is going to be equal to the square root of, if I use this right triangle, one side is 2mv, the other side is mv, so I have the square of the first one, c squared is equal to the square root of c squared is equal to a squared plus b squared, or my c is equal to the square root of a squared plus b squared, right? Pythagorean theorem. So momentum is my hypotenuse and equals to the square root of the square of the first one, which is 4, m squared v squared plus square root of the second one, it's m squared v squared. So the strength of the momentum, the resultant momentum between these two, is equal to mv square root of 5. Then the third one must be having exactly the same momentum. So this momentum, they have to cancel each other. So the momentum of the third one has to be mv square root of 5. And I want to find out what's going to be the magnitude of that velocity. I know that the third one is going to have its mass, its velocity. So it's going to be its mass times its velocity. I'm going to say the velocity of the third one. That's the one that I'm looking for, v3. If I look at this equation, I can cancel m from both sides. So v3 is equal to the square root of 5 over 3v. So the direction of the resultant vector for the third one is going to be opposing the one that is resultant in that direction. The length of them should be the same, they're equal to each other. So that's how I know the blue one is also equal to that number. But I also know that the third ball has the 3 times the mass and moving with its velocity, which is v3, and I can find what v3 is equal to by solving this equation. That's another very good example and very common probably for these type of questions, very common for AP exam multiple choice. In this question, again, I don't have the picture of the question itself, so I'm just going to tell you what it is. An object X of mass, let's say 5m. So I'm going to have one object with a mass of 5 kilogram, and moving with the velocity of 3 meters per second. And the other one is the 2 kilogram, is at rest, so its velocity is 0. Object X then collides with and sticks to the other object Y. After the collision, X and Y stick together, and how much mechanical energy is converted into non-mechanical energy during the collision? So if this was on the plane, then I have momentum before is equal to momentum after. Momentum before is the mass of the first, the velocity of the first plus the mass of the second, velocity of the second, and afterwards they stick together, so it's mass 1 plus mass 2 and their velocity together. So for mass 1, velocity 1, I have 15, 5 times 3 plus 2 times 0 equals to 7 times v. So v is equal to 15 over 7. So that's the velocity after the collision, meters per second. Now they ask me about not velocity of them after the collision, but how much mechanical energy is lost. So I'm going to look up at how much kinetic energy I had before the collision. So I have the kinetic energy of the first one, mv first squared, plus the kinetic energy before the collision of the second one, so m1 m2 v2 squared initial. And because the second one was not moving, I have the mass of 1/2 of the mass of the first one times its velocity squared. So that will give me 22.5 joules. And then kinetic energy after the final, they stuck together, so I have 1/2 their masses together and their velocity squared together. So I have 1/2 the mass, their mass together is 7, and their velocity after the collision, the one that we found, is 15 over 7 squared. And that will give me 16.1 joules. And if you subtract one from another, so the change of the kinetic energy compared like before and after is equal to 6.43. I rounded there a little bit, so 6.4 joules. So this is how much energy is lost, and probably to some damage between the balls or sound, some friction. So that's how much energy was lost in the collision. That means the collision wasn't elastic because the energy before is not equal to the energy after. If energy before was equal to energy after, kinetic energy, then you could say this collision was elastic. That's the only way you can say that collision was elastic. Here's another interesting question. I have a motor, and so it's attached to subfloor, and this motor is pulling the mass, and I'm gonna say the mass of it is 5 kilograms. So a 5 kilogram block is attached to a light cord that is wrapped around the pulley of an electric motor, as shown in the figure. At what rate is the motor doing the work? So when they say at what rate the motor is doing the work, they ask about the power. So that's going to be the work done over time. When it is pulling the block upward with a constant, with instantaneous speed of 3 meters per second. So at the moment when it is going to be 3 meters per second, the question is asked how much is going to be, how much work or power is going to be applying on the mass. And then the upward acceleration is 2 meters per second squared. So the acceleration at this moment is 2 meters per second squared. And this question, as many of their questions, is really tricky because you have to recognize something over here. So at first, this formula is not given. You have to know this formula by deriving it. So the work is equal to the force times the distance and over the time, and the distance over time is the velocity. So the formula is not given to you, but you have to know that there is another way to represent the power. So again, when they say rate, at what rate the work is done, the work is done is the work done per time. That means they ask about the power. So at first I'm gonna do my free body diagram with my forces. I have tension, I have mg, and I have acceleration. So I have tension minus mg is equal to mass times acceleration. So the tension is equal to mg, which is 50, plus mass times acceleration, which is 10. That gives me 60 newtons. And then I have the power is equal to the force. In our case, it's tension, which is 60 newtons. It's going to be tension times the velocity. So that's going to be 60 times 3, and will give me 180 watts. So this is the power that the motor has to supply in order to move this block at 3 meters per second and accelerating at 2 meters per second squared at that moment. In this question, you have a ball, and it is stationary on the ground, and then comes the person who's going to kick it. So this person kicks the ball at some velocity. So let's call this velocity is 10 meters per second. And the mass of the ball is 0.5 kilogram. And let's say the angle at which they kick it is given. And so this angle is 30 degrees. And the question is, the magnitude of the impulse imported by the ball on the foot is most nearly. So when you or the person kicks the ball, you or the person applies the force on the ball, and the ball applies the force on you. and that force times the time how long the foot was in contact. So this is the force, and that is the force. So the time and the force that was applied on the ball is impulse and equals to the mass change of the velocity of the ball. So the impulse has the letter J and measured in newtons times seconds. And then the mass is given, so that is 0.5, and the velocity is 10. So J is equal to 0.5 times 10, which is just 5. So that will be 5, and measured in newtons times seconds. Here is another question, and in this question they say a spacecraft of mass 1000 kilogram is traveling in a straight line in the positive direction. Engines can be fired so that the force exerted on the spacecraft is in the positive or negative direction. The graph that is shown shows the data of the force during the one interval, so it's between 0 and 8 seconds. Which of the following is the best? So they give you multiple choice questions. The best estimate of the net change in the speed of the spacecraft from the moment t equals to 0 to t equals to 4 seconds. So I have to find the change of the speed within these 8 seconds. So I could estimate the graph right here between 500 and 300 newtons to 2 seconds, and then looks like it's gonna be 0 right here, so in my graph, and then it's gonna jump to 5 seconds and stays flat all the way till 8 seconds, or maybe I'll do it in red. So I'm estimating my graph to look something like this if I connect the dots, so between 3 seconds and 5 seconds, and then stay straight. We talk about this in the classroom, students ask, so some of you will know, some of you will never hear it, unless you watch this video. So here you see the area underneath this graph, and I want you to pause the video and try to answer what the area underneath this graph represents. And so I hope you paused it. If not, you just pause it right now. I want you to try to answer what that area is equal to, and I'm going to continue with the video. So the area underneath the graph is equal to, it's the height times the width, 1/2 for the triangle, right? So it's the height times the width, and that is force times the time. And force times the time is called impulse and equals to mass change of the velocity. And they ask you estimate the net change of the speed of the spacecraft. So I need to find the total force times the time over the whole interval of the time. So I'm gonna break it into 3 different intervals. So this is the first interval. So force times the time, the area underneath is equal to 300 newtons times seconds. Then the area underneath between 2 and 3 seconds is 0 because it's flat. There is no force acting between 2 and 3 seconds. And then for the next interval right here between 3 and 5 seconds, I'm going to calculate that area, and I'm assuming that this is 100. So that's going to be at 1/2 times the height times the base. So it looks like that part is going to be 100 newtons times seconds. And then the last part, I'm going to make it in red, is the area underneath that part of the graph. So the time is 3 seconds, and it was the force was negative 100. So that is negative, and the other one was negative as well. So for this one is also negative because the force is acting negative. So, and for the next part is going to be the height is 100 and 3 seconds, so negative 300. So the total change or the impulse acting on the spacecraft is negative 100 and equals to the mass times change of its velocity. So from here I can see that the change of the velocity of the spacecraft was equal to negative 0.1 meter per second. So the spacecraft lost 0.1 meters per second over these 8 seconds. If they give you initial velocity of the spacecraft, you would be able to calculate the new speed, but because initial velocity wasn't given, all you had is the graph, and they ask you about how much velocity changed. So all you have to find is the change of the velocity. So in this question, they say that a person holds a 2-kilogram block at position A shown on the left side. And at the constant width, at this moment, the spring is unstretched or uncompressed and has a spring constant of 500 newtons per meter. And the person gently lowers down the block from rest at position A to rest at position B. So the picture on the right. And then which of the following describes, they give you multiple choice, the change in energy of the block system, spring earth system, as the result of the block being lowered down. So the energy that is lost by the block, so the block used to have the potential, so here we have the block's potential energy, which is mgh, and the height is 0.2, so this is 0.2 meters. And it loses 10.1 meter, but the initial position at point A is mgh, so that will give me 4 joules of energy. Mass is 2 and g is 10, and the height at that moment is 0.2 meters, so that gives me 4 joules. Now at point B, I have potential energy still, and then I have potential energy of the spring and potential energy of the block. So potential energy of the block at B is equal to mgh, so you have m, g, and h is now 0.1, so I only have 2 joules of energy left for the block. And then I have potential energy of the spring at this moment as well, because the spring is compressed, 1/2 kx squared. So that is 1/2 500, and then times x squared, which is compression, is 10 centimeters, so that is 0.1, and I'm using the green 10 centimeters, the one by it was compressed by. So from here I will get that that is equal to 2.5 joules. If you compare how much energy the system had before and how much energy the system has after, so for after I have 4.5 joules, and before I have 4 joules. So if you compare the energies, then I can say that the energy of the system increased by 2.4 joules. So it's the difference between these two guys. So the energy of the system increased by 2.5 joules. In this question, they say a 60-kilogram athlete is running at the speed v, grabs the light rope that hangs from a 10-meter height platform, and swings to a maximum height of 1.25 meters. So he's gonna swing to some height, 1.25 meters. Then later on, they're not related. So later on, another 120-kilogram runner is running with the same speed, so they both have the same velocity, and grabs the similar rope hanging from 5-meter height platform And the question is, what's going to be the maximum height to which the 120 kilogram athlete will rise? So I'm going to work up the problem for the first one first. You have kinetic energy of the runner, which is 1/2 his mass velocity squared. So that's the velocity at which he is running, and the one that they both have the same velocity, is equal to his potential energy, because all this kinetic energy is going to go into the potential energy. So that is mgh. And you can see here that the energy does not depend, or the height will not depend on the mass, it will depend on the velocity. So from here I can see that the velocity to which he rises is equal to the square root of 2gh, the formula. And then you have the square root is equal to 2. And then I have 10, and h is 125. So the velocity is equal to 5 meters per second. Now, the second runner was running with exactly the same velocity. So his kinetic energy, which is 1/2 his mass, I'm going to call it this way, m, and his velocity, which is the same as the previous one, is equal to his mass, g, and height he will go to. So again, I can cancel his mass, and I have 1/2 v squared is equal to gh. I'm going to plug in the numbers, and I have 1/2. The velocity is the same, the one that we just found, which is 5 squared equals to 10 times h. And from here you can see that the height is going to be the same, 1.25 meters. In this question, they say two objects of mass 0.2 kilogram and 0.1 kilogram respectively move parallel to the x-axis as shown in the figure. 0.2 kilogram object overtakes and collides with a 0.1 kilogram object. Immediately after the collision, the y component of the velocity of 0.2 kilogram object is going to be 3 meters per second. And the question is, what will be the y velocity of the y component of the velocity of 0.1 kilogram object? So this velocity is unknown. And think about it, if you're looking, this is like the top view, like billiard balls. If they're coming one toward each other, then they will just collide and go apart. But if they're not aligned on the same line, then they will go in two-dimensional collision. So your vertical components of the momentum must be equal to wherever you had vertical components of the momentum before. And neither of the block had vertical component of the momentum. They had velocities forward, but not vertical. They had horizontal velocities. So the momentum of this one, vertical 1, must be equal to the momentum, letter P, momentum of the second one. So momentum of the top one, vertical, is going to be equal to the mass times the velocity, which is 0.6 newtons times seconds, or kilogram meters per second. You can use either one. And momentum of the second one needs to be the same 0.6. But it equals to its mass times its velocity. So from here you see that the velocity of the second one must be 6 meters per second to cancel each other. And I don't have time to finish all the problems that you guys sent me, so I'm gonna just call this one number 1 for our midterm review video, and I'm gonna make the second one later on. And thank you for watching this video, and I'm gonna see you in the next one.